Hey, welcome back to the stream. So tonight's going to be a really short stream. I don't have that much time. I have to go join my girlfriend and do a little bit of babysitting. But I did want to spend a bit of time just working on a few things on the keyboard. So last stream we were quite lucky, or not lucky, but we made some good progress, and we got the both brackets on this side and on that side of the keyboard fitting quite nicely inside the keyboard, and the switches were nice and centered and everything. But the thing is that this kind of, like, if I push on the switches on the underside, you can see that it kind of just pops out easily, which is not great. So we need to find a way to make this stick in there and not pop out. And there's a few ways I was thinking of doing this. Now let me just pull up the focus controls for this camera. All right, so if you look here, oh, the lighting's terrible. Oh, that's not too bad actually. All right, there we go. If we look here, let me move the soldering iron out of the way. All right, here there is actually a place for a screw that is not used at all in the original keyboard design. The motherboard mounts here, and I think that the key wells on either side, they actually mount in this screw hole. This one is not used at all. I don't even think it's tapped, to tell you the truth. I think it's meant to be used by self-tapping screws. And there's one on either side. It's symmetrical, which is good for us. There's also this little thingy here, this like sort of rectangular, I don't know what that is exactly. I don't know what it was meant for. You know what? I don't even think the original PCB stretched that far. Let me pull one out. So this is one of the original backing plates for the PCB. I can't even tell which side is which, and honestly, I think it's like this. There we go. Okay, so it was used kind of as a support, I guess. Yeah, to make sure this thing didn't pop out, to make sure the end didn't bend, maybe? I'm not sure. Anyways, we could extend our little box here past to this thing. We could even maybe print like a little like a tube of sorts, if you will, to not a tube, but like a square section tube, if you will, to kind of wrap around this. But my main goal is to get to this screw post here, so that we can screw our the whole PCB in there. My friend Tony actually suggested a clever name, I thought, for the PCB technique that I'm working on right now. He suggested to call it CT PCB, for copper tape PCB, which I think made sense. So I'm going to adopt that from now on. Thank you, Tony, for that suggestion. Now, on the other end, on the other side of the keyboard here, there's not much to hold the CT PCB in place. There you go, first use. So what I'm thinking of doing is actually printing things on the underside here. They're going to stick out of the PCB and rest against the bottom side of the keyboard. Now, when I say bottom, I say this is the top side of the top side shell, right? So there's a bottom side shell that goes and kind of clamps underneath this. And as it turns out, since I've got all the keyboard guts out of there, well, most of them actually, there's still a circuit board in there, but I think it's the USB stuff mainly. Actually, come to think of it, I don't even know what that is. King Key 31 Pi-Eng. I'm not sure. It seems to be branded with non-Kinesis stuff. So if I put the shell together, we can actually see the space that's in there. I can print my stuff. I can see how it feels. I can actually see through the massive hole in the key well whether it actually rests up against the key well properly or not, which is great. It turns out it's really gonna help us. So without further ado, I'm probably gonna just flip right over to Fusion 360, take some measurements and stuff, and start modeling the stuff right away. I wanted to mention that last week I was printing some parts for my printer, and I was really unlucky. I had a bit of a failure overnight, and it was kind of worrying actually. When I got up in the morning, all the cables were melted. There were short circuits. It's pretty much a miracle that I didn't fry anything or worse. You know, I've got a smoke detector right above the printer and an extinguisher right underneath. So I would have been prepared, you know, had there been an emergency, but still, I was really surprised that nothing burnt out. I was able to kind of cut out some of the burnt wiring and splice it and make some new cables, and everything worked fine. The driver still worked, the extruder motor still works, but I wonder if I can actually maybe show a picture or two here. Let me just quickly find a picture there. It was not awesome. Yeah. So check this out. The heater was pulled out halfway, which is really bad news because the heater can actually, you know, touch stuff and ignite it. It's really quite warm. This was melted cable insulation all over my heating block. Really quite terrible. You can see that it was quite. You see, this heating block was shiny before the failure. You can see the thermistor actually has been pulled out halfway, which is really bad because it means thermal runaway. The printer is going to just heat and heat and heat until it, you know, basically never stops. Except I've got Marlin on there. When it detects thermal runaway, and I think after a minute it cuts out the power to the hot end to avoid thermal runaway. This is the fan. It got knocked out. It actually pulled some screws out. You can see there's a screw pulled out here. This is the cable that caught on the model I was printing, and yeah, you can see like basically melted cables over here, maybe cables over here. More cables there. Those are the servo wires. There were 3 that were shorted together. The fan wire there. Anyways, a pretty big mess. You can see some carbonized crap just all over the print bed. It's really no good. But the printer finished, you know, it was homed and everything, so it was none the wiser. Yeah, there you have it. All right, let me switch over to the desktop. Okay, we've got the Fusion. Boop. Sorry, I played around with like swapping my primary and secondary monitors there. All right, so we said, actually let me turn the printer off quickly. All right, take some measurements, take out the calipers. All right. So I'm going to quickly measure the edge of the switch well, I guess you could call it, to this kind of like rectangular protrusion. I'm really gonna have to guess at this one because my model doesn't actually line up. It doesn't end exactly where the sorry, let's say 4 millimeters, where the edge of the I've got 2 edges that don't line up. One that's inside the keyboard. My model doesn't actually make it all the way to the edge, so I don't know what the delta in measurement is there. I guess I could measure that actually. Where's the... There we go. So I'm just gonna measure this. I'm gonna put this back in there. And then I'm going to measure. Yeah, all right. And it's really just eyeballing it there. I'm gonna go and say that that's about 3.7 millimeters. And the beautiful part about this is we can do it once and it will do everything symmetrically. Is this the mirror? R pattern? No. This is the mirror. Okay, so if I go before the mirror, that is suspicious to me. Was I really working on... Oh yeah, I was working on that side first, that's right. Really? Yeah, okay, sorry. Brain fart there. So that means that this side is the side that I need to extend. And that is actually the first, you know, I'm actually going to do this pre-split, and then I think I'm going to extrude this face out by an extra, we said 3.7, right? Do I want to extrude the whole thing though? Not really. I kind of want to cap this off. Okay, I am going to extrude it a bit first by, say, just a little bit, about 1 millimeter. All right, so I'm going to give it 1 millimeter, and then I'm going to cap that off. So I'm going to create a sketch here in this plane. I'm going to project this, hide the body, then I'm going to draw here like that, stop the sketch. All right, extrude from here and here. And I said 3.7, so that's an extra 2.7 millimeters there. All right. Okay. Now that should line up nicely with the inside edge, or I guess outside edge of that little ridge I showed earlier. I know this is hard to follow without on the camera, but I'm basically, you'll see as I model what I'm trying to do there. Now the outside edge would be what, an extra 8-ish, 8. Let's call it 8 from the edge. So that was what? Wait. I want to say this is 5 millimeters wide. All right. .7, so that would be 7.7, and then, oh man, this is going to be quite, there's going to be a lot of iteration for this part, I think, because it's at so many different angles and stuff. Okay, so this is about 5 millimeters wide-ish, 4.5, well, 4.8, let's call it 4.8. Okay, so let's create a sketch here in this plane and project this guy. And then we said, oh, rather, I actually need to add an extra millimeter here. Okay, so that's going to be a millimeter on the inside. All right. Okay. Like this. Millimeter on the inside. And we said 3.7 from this side. That's correct. Okay. That looks about right. And then oof. All right, so in this plane, this is very close to the edge. It's a good... Actually, if I model this, now that I think about it, I'm not sure this is a completely good idea, actually, because if I want to use this, if I want to be able to slide this in, if I want to be able to slide it into the key bracket, this can't be very deep. I could have like just a very light registration contour there. That would work. All right. It's one of those things, right, where you design it once and then after that, every copy you print, it's forever better because of this. So it's worth taking the time. Okay, this is the side with the gaps, which means that this side here is 1.7. And then on the other side, this doesn't. $13mm across. So it is not bad actually. It's eyeballing. Okay. But those are tight measures though, so I'm actually going to add a little bit to this. So say whatever. I'm going to offset this guy outside by -0.2. Yeah. Okay. And then I'm going to extrude this outwards by 0.5 millimeter, something like that. Okay, that looks okay. And then let's try to reach the screw hole, which is at an odd angle, and whoa, this is going to be something. All right, so the screw hole is more than 28 millimeters away. Yeah, let's call it 28. All right. So I don't think I want to extrude this whole thing though, this whole profile. So what I'll probably do is I'll create another sketch here. I'll project this end again, and I will make a horizontal thing parallel. Okay, and then make this say 2 millimeters thick. Stop that sketch. And then just measure from here to here, 8.7. All right. Okay. Ah, wait. This won't quite print right because there's no support here for this. Though I don't really care about the finish for this part, so we could actually have this print with support. It would just be under this part. Yeah, that'd be okay, I guess. So let's just check. If we fast forward to the end, still works. All right, nice and symmetrical. Boop. You know what? I'm not actually sure about this being 0.5 millimeter. I think that's a little too much. Because it needs to fit properly, it needs to be like, to fit exactly, it would need to be drafted or something so that it would be on an incline, and that's more trouble that I want to go through. Okay, so we said 28 millimeters to the center of the screw post. That would be something like 25 and a half. 25 and a half. Okay. So, ye olde project. Okay, so let's make this a construction line, and then, oops. 25 and a half. And then, and there's an epic amount of eyeballing going on here. What kind of an incline is this? Wow. Actually, no, this is not what I'm going to do. thinking a little ahead here. Alright, it's time to try something crazy. Yeah, I'm going to suppress this for now and show that sketch again. I'm going to construct an offset plane from this guy, 19.3 construction. I'm going to create a sketch in this plane, and what I'm going to do is I'm going to, okay, let's just think about this for a bit. So I'm going to draw a rectangle, which then, nope, I want this and that. Well, actually, you know what? Let's undo that. Okay, so let's draw a little horizontal line and then draw a line like this, which we'll set at a given angle, which we don't care about for now. This guy will make it perpendicular. This guy will make it, yeah, okay. And then this guy will be perpendicular as well. Perpendicular. Yeah, didn't like that, okay. So let's try modifying this constraint here. All right, this works. Now, what I'm going to do is I'm going to loft from this profile to this profile. Sure, that'll work. My only problem is that I don't actually want this to be so far out. I'm going to take this back a little. Instead of 19.3, let me knock, like, say 6 millimeters off that. So 13.3, and then I'm going to show this guy again, construct another offset plane here. Or rather, sorry, I actually don't need to do that. Yeah. Okay, sorry. I can extrude this by 6 millimeters. There we go. Okay. It's starting to look a bit more interesting. Okay, so now I just have to get the right sizes. Alright, unfortunately, I think this is almost all I'm gonna have the time to do, but I just wanted to try to tweak this curve so it looks a little more interesting. It's going to be up. In this case, yes, up. No, yes, up and to the other side. So in this case, I mean minus 30 degrees. What? Okay, there we go. And then I can move this guy around. Oh, I see what's going on here. Okay, let me constrain this a little more. And I don't actually need this to be that long. Let me make it like, whoops. Was it 15 millimeters now? Whoa, why are you complaining about over constraining? I think I must have misclicked there. And now the idea is for the corner, yeah, that's kind of the wrong corner. Okay, let me quickly get rid of this line here. I want this corner to be horizontal, and I want this angle to be 30 degrees. There we go. Now if I hide the body, or good old project, and then constrain these to be, well, you know what, I can just get rid of this. Say this point needs to be on this line, coincident, and then give a dimension here. There we go. Now I can move this back and forth, and then the angle stays constant. So if I look at what this looks like now, looks a little better. All right, so I'm going to guess at where the hole is going to be, just so you can get an idea of, whoa, what happened there? Okay. And this face here, there's where, okay. And then, oops. And then make a circle. There'll be two circles, sort of a one for the screw. Actually, I only really need one. I'm going to make it in the middle here. And say that this has to be coincident. And then when I go like this, and pop this guy right through. There we go. So is that even on the right side? It is closer to the grooves. No, I'm going to, oh, sorry. Edit to sketch. Move this further like that. All right. So hopefully that gives you a good idea of my design process for this part here. I'm going to probably spend a bit more time just measuring some more and tweaking some distances and stuff. And I'm probably going to print, isolate just this part here, the last key bracket, and print that part a couple times and iterate on the exact dimensions. And then hopefully we'll wind up with a part that can be just screwed right into the keyboard. And once that is done, oh yeah, I've still got to put the sort of the prongs on the back here to make sure that it sits properly against the back of the keyboard case. Unfortunately, I won't be able to stream tomorrow. I'm helping my parents move. They are changing houses after 27 years in the same place, so they're going to be packing a big truck and going on a big road trip and stuff. So I won't be streaming tomorrow, but maybe Saturday, we'll see. So thanks for joining in. This was a bit shorter, but I appreciate your time. Until next stream, have a good one.